Good morning, dear students. Today we have to continue the last part of the activity 5 about the nature of nervous message recordable electric signals. At the end of this video, you will be able to list the properties of a nerve fiber and a nerve, to describe the effect of myelin, diameter and temperature on the speed of the nervous message, and to calculate the speed of propagation of a nervous message. Let's remember the difference between nerve fiber and a nerve. First, both of them, the nerve fiber and the nerve, respond when they are effectively stimulated. So they don't respond to ineffective stimulations. Why? The response of a nerve fiber always have a constant amplitude. So it obeys the law of all or none. While that of a nerve have increasing amplitude, so the nerve responds to the law of summation. The speed of some nerve impulses is high, such as the impulse that travel the muscles, while others are slower, such as the touch or the pain. Why some nervous messages are faster than the others, and what are the factors that affect the speed of propagation of nervous message? So we have to study the factors that affect the speed of propagation of nervous message. Observe the following video. When we make a stimulation, first, for the non-myelinated fiber, it propagates along it. Same for the myelinated fiber. This is a stimulation on a nerve. When the stimulation increases, the response of the nerve also increases. So, we have two properties of the nerve and that of a nerve fiber. Both of them respond to effective stimulation. They can convert the change into response called action potential, so they are excitable. And both of them conduct the nerve impulse. So the response is recorded at a distance from the stimulation, so they are conductive. So the nerve and the nerve fiber are excitable and are conductive. They are excitable because they can respond to effective stimulations, and they are conductive because they can conduct this stimulation along the nerve or the nerve fiber. Now you have to pause the video, prepare your notebook and a pen, and solve the following exercise, then correct it. The following table shows the speed of nerve impulses in different types of nerve fibers. All these measures are carried out at 38 degrees Celsius. You have many questions to answer. Now we have to correct the answers. First, they ask to analyze the results for the myelinated fiber, which are the three first experiments. When we have to analyze, we have to make a link between the diameter and the speed. When the diameter of the fiber was 20 micrometer, the speed of nerve impulses was 120 meter per second. As the diameter decreases from 20 to 2 micrometer, the speed decreases from 120 to 12 meter per second. What can we conclude? That the diameter of the axon is a factor affecting the speed of propagation of a nervous message, because, as an explanation, when the diameter changes or when the diameter decreases, the speed decreases. So the diameter is a factor that affects the speed. The second questions, we have to talk only about the experiment 3 and 4 for the fiber with myelin sheath in the third experiment and without myelin in the fourth experiment. They both have same diameter, which is 2 micrometer, but the speed is different. The controlled variable is the variable which is constant in both experiments, which is the diameter of the axon. It's 2 micrometer in both experiments. The manipulated variable is the variable that we change before applying the experiment. We change the state of fiber. The fiber here is myelinated, while here is non-myelinated. The myelin sheath is the manipulated variable. The responding variable is the result, the affected one. What are we measuring? We are measuring the speed of nerve impulse. As a comparison between the speed in two cases, the speed of nerve impulse in the myelinated fiber having 2 micrometer is 12 meter per second. When we have to compare, we have to say smaller or greater than, which is greater than that in the non-myelinated fiber having the same diameter, which is 2 meter per second. What can we conclude? What is the factor here affecting the speed? The factor here is the myelin sheath, which speeds up the propagation of nervous message. Now we have to watch the following video, which talks about the 3 factors affecting the speed of propagation of the nervous messages.
Myelination, axon diameter, and temperature all have an effect on the conduction rate of an electrical impulse. Propagation of action potentials along axons of neurons that are not covered by a myelin sheath requires that all of the membrane must undergo depolarization. This kind of conduction occurs along unmyelinated axons and is called continuous conduction. In the peripheral nervous system, Schwann cells form myelin sheaths by wrapping their cell membranes in multiple layers around an axon. The axon is now electrically insulated except for the gaps, called nodes of Ranvier, where the membrane is exposed. Because myelin electrically insulates an axon and prevents ion currents across the membrane, depolarization of myelinated axons occurs only at the nodes of Ranvier. This form of conduction, where the signal appears to leap from node to node, is called saltatory conduction. Energy efficiency and longer distance between depolarization sites make saltatory conduction much more rapid than continuous conduction. Larger diameter axons conduct action potentials more rapidly than smaller diameter axons. This is because there is less resistance to carrying a charge in larger axons. Axons that are cooled, as with application of ice, conduct action potentials less rapidly than axons that are warmer.
So, as a conclusion, we have 3 factors that affect the speed of propagation of nervous message: the myelin sheath, which speeds up the propagation; the diameter of the axon. When the diameter increases, the speed will increase; and the temperature, also when the temperature increases, the speed of propagation increases. Now, if I want to calculate the speed of propagation of the nervous message, we have to apply the same rule applied in physics. So the speed is delta D over delta T, D for distance and T for time. For example, this is an experiment. This is delta D, which is the difference between the distance D2 minus D1, and the delta T is the distance between the 2 peaks obtained on the screen of oscilloscope. So S is for the speed, delta D the distance between 2 oscilloscopes, which is here D2 minus D1, delta T the distance between 2 peaks, which is here the distance between 2 peaks on the screen of oscilloscope. As an application, we have this figure. They ask to calculate the speed. First, we have to write the rule S equal delta D over delta T. So delta D is D2 minus D1. D2 is 20 millimeter and D1 8 millimeter. And delta D is 0.1 millisecond. So to convert from millimeter to meter, we have to multiply by 10 minus 3, and to convert from millisecond to second, we have to multiply also by 10 minus 3. They are eliminated both together, so the response is 100 meter per second. For the next time, you have to study the summary sheet part 4, and we have test or quiz in activity 5.